Good. Okay. So our project is language recognition. Obviously, Nathan, Rockford, Evan, that's us. So the goal of our project was to obtain language of like a bunch of different languages from around the world and compile a data set in which we could parse those language files and then be able to try and determine the language that is being spoken, and also like test it on new files that it hasn't seen. Originally, we had hoped to do a lot of language files or a lot of languages. I think we had like a plan of 10. It got a little more difficult than we thought it might, so we ended up only being able to do 5, but we got pretty far. So the goal is to break them each speech file into phonemes. And what phonemes are is you can kind of see they are like different little blurps or distinct units, as the definition says, of sound. And so like so like those are all different phonemes of spoon. And so we wanted to break it down into those phonemes and then count those phonemes up for every single language file, and then see if we could use a perceptron or other things to categorize the languages according to which phoneme is available. And that's kind of what this goes through. And so we were going to go from the language to phonemes and from phonemes to a data set. And this got a little more difficult than we had hoped, but that was the goal.
Okay, so we found out that there's a library called Pocket Sphinx for Python, where we could take our audio files and convert them into, these list of phonemes that we could then use for our machine learning algorithm. Yeah, like it says, it's developed by Carnegie Mellon University. It's language and speech processing, does all sorts of things that has to do with the audio files and parsing the audio files. It wound up being pretty difficult because like there was just a lot going on with the library and a lot of things you had to know. And so, we Googled and Stack Overflowed and eventually figured out a way to make it run. It was hard. It was hard because we had to deal with different audio file types. So there were MP3s and there were FLACs. It turned out that we figured out with trial and error that the WAV files were the best to run, and so that took quite a bit of time just to get that to run. And we ended up using Google Colab because the library wouldn't work very well on our computers. Next. And yeah, so we eventually got it into these lists, which we see here. And if you see SIL is the beginning of the sentence, the silence, and then after that it's all the phonemes. So we ended up having about, I think there were like 200 different audio files per language, which wound up being pretty good for testing into our model. And then yeah, we took all these and stuck them into a big array that we could then stick into different machine learning models. Next. And yeah, and then they wound up like this. Nathan, it's your turn.
Yeah, so these are, what you're seeing right here is the different counts of each phoneme that appeared in a particular data point. So if this first data point is an audio of someone speaking, then that would mean that the phoneme AE that occurred 1 time when they were speaking, and then L occurred 6 times. We then took that data and normalized it. The reason normalizing was really important is because the audio clips were of varying length. So one phoneme could occur a lot more frequently than normal because of just the fact that the audio clip was longer than the others. So by normalizing them, it made it so that the audio length was not a factor in distinguishing between languages. Can you go to the next slide? So yeah, we chose multi-layer perceptron to be the initial model that we tested on. The reason we chose that is because there are a lot of phonemes. There are 40 in English, and we didn't want to use a model that would take a long time with that many features like K and N. And also we wanted we wanted multi-layer perceptron because we anticipated that there would be distinct differences between each of the languages that the multi-layer perceptron would be able to find. We also tried decision tree. Decision tree was not quite as accurate. With multi-layer perceptron, we were able to get 98% accuracy when we ran a 10-fold cross-validation test on it. And with decision tree, we got about an 86% accuracy. And so we had a lot of ideas for what things that we could do with this if we had a little more time. For example, accents. If we had time, we would definitely try to run this model to see if it could determine the difference between accents, actually, because you use different phonemes when you speak with different accents, even in the same language. And I think we would have had success if we had tried that. In addition to that, we really wanted to try and implement real-time language classification, but that would have taken a lot more time actually to implement. You want to move to the next slide? Oh, yeah, and that's it. And overall, it was a really cool experiment, and we got really good accuracy, which was, to be honest, it wasn't super surprising because we knew in advance that phonemes were very good indicators of what kind of language someone was speaking. But it was really cool to be able to get 98% accuracy when we finished running it.
Yep. Cool.